Alrighty. So this is going to be interesting. I didn't know exactly where in the series to put this, so I'm putting it here. And it's going to be more framework code, because that's, well, the theme of this section. But it's going to look a little weird, and I'm going to try to break it down as much as possible. But the first thing I want to do is show you guys the motivation of what I want to accomplish. What I want to accomplish is a very easy way to create asynchronous operations that can be invoked from the client to on the server. But I want to do it with as little code as possible every time we want to invoke a new possible or create a new possible command. So what I'm going to do is I'm going to create a couple sections here inside of my observable socket. We're going to have emit, which is client side, and then we're going to have our on, which is server side. And I'm going to stub out two methods. I'm going to stub out emit action money, action arg. Now remember, the money suffix refers to the fact that this is going to return an observable sequence. And right now we're going to return observable.empty. Whoops, empty. Now, obviously we'll be filling this in, but again, this is about the motivation of what I want to accomplish. I find it really helpful, actually, to do this when I'm building an API, to stub out kind of what I wish was there, and then see how it would work on the code that would consume that API, and then actually go in and implement the API. So that's what we're doing here. Then on the server side, I want to do on action, callback. And this is just going to be empty. So how would I use this? Let's delete this code here. I don't need that anymore. Let's say we want to write a command on the server that authenticates a user, a login command. So what I want to be able to write on the client, I want it to be the simplest code possible. So what I'm going to do is I'm just going to write out how I wish it would look. I'm going to say services.server emit action money login. Remember, emit action takes an action and an argument, and the argument will be username, foo, password, bar. And then I want to subscribe with the result. Goes into if result error, console error, result error, otherwise console log, we're logged in. So this is what I want the client-side code to look like. I emit an action with a action name and an object, and I receive back an observable sequence that I can subscribe to. And when I subscribe to it, I will get the result of that action when the server is finished doing whatever processing it needs to do. And so what we're going to do in the background is we're going to submit this request to a server. We're going to apply a special request ID, and that request ID is going to be sent to the server. The server is going to do its asynchronous operation, and then it's going to send back a response using that same request ID, so our client-side code knows to invoke this bit for this particular login. And we want that entire thing to happen behind the scenes. So let's see what the server side would look like, how I imagine that. Well, on the server, what I want to do, first of all, I will remove this code that's just sending on index. First of all, we need to import our observable socket from the inside the server code. So let's scroll all the way to the top of the file, and let's import observable socket from shared observable socket. So now we have access to our shared observable socket implementation. And then I'm going to scroll down here, and I'm going to say const, and I'm going to actually call this client equals new observable socket of socket. And then to handle login requests, I want to say client.onAction, onAction login. And then I want to receive the data, the credentials, we'll just call them creds. And then I want to return an observable sequence from the client. Like, for example, we might want to say return database dot find user, and then username is creds username, and then after we find that user, then we'll Actually, I want to make it clear that the find method will return an observable sequence, and then we'll say something like flat map user goes into if not user or user password does not equal creds password, then return observable dot I don't know, throw user not found, otherwise return observable of user. And what the benefit here is that the code is incredibly succinct and it allows us to perform asynchronous operations. So the find method is an asynchronous operation, and we're returning a stream out of this. So that's what I want the client side to look like, or the server side to look like. I want the server side to be able to go off, do an asynchronous operation, hit a database, hit a web service, hit whatever, and we're going to see examples of that in this series. But of course, we have to write the observable socket first, and then I want that all to magically work. And then I want this data to be returned, whatever the thing that this returned, I want that to be sent right back into the client. Again, with as little code as possible. I know that this is seemingly very complex, and it does take time to get your head around, and the reason I am introducing this so early is because we're going to have so many examples in this series of code that would traditionally be very ugly, classic callback hell, sort of nasty asynchronous operations. And we're going to clean them up with this API. So let's go ahead and rewrite this using something that'll compile so that we can test our progress as we move along. So I'm going to remove this example specifically, and I'm going to scroll back to the top of this file and import our observable from RxJS. So I'm going to import observable from RxJS. And then I'm going to scroll down to the bottom, so make sure you import that. Then I'm going to scroll back down to the bottom when we do our onAction login, and I'm going to say return observable dot of username is bleh. Or how about username is creds.username, so we can prove that we're actually receiving the data from the socket. I do have an error over in my application, bar is not defined, so let's go ahead and quotify that. Anyway, so this is our little test case of our emit action and our on action. So let's do our on action first. But what I am going to do is I'll go ahead and close these out because we're going to need the space. I'm going to pop open our observable socket. What I am going to do, though, is on our on action, I'm going to do some debugging. I'm going to say this.socket on action, and then I'm going to say args, or ... args, goes in, well, you probably have to put that in brackets, ... args, goes into, and we'll say console log args. So what we're doing here is on our on action, right now it's just in debug mode, where it's going to print out whatever the emit action from the client sent to the console so we can kind of watch our progress, so to speak. Okay, so emit action, how are we going to do this? Okay, don't write this code out, but this is basically what we're going to do. For the emit action, we are going to basically say this socket on action, and then we'll do success. And then we're going to do this socket on action, whoops, other way around, action fail. So what we're doing here is we're going to preemptively bind to the two events that are going to be sent back from the server. Remember, this is what's going to be used on the client side. This is what's going to be what we're going to be using on the server side. I know it's kind of weird to see code that's going to be executing in two different contexts at the same in the same place, but that's just the nature of sharing code in Node, and it's best to get used to that. Okay, so that's basically what we're going to do. We're going to bind to these actions, and we're going to send out a request ID when we emit. So then we're going to say this socket emit action arg request ID. And the request ID is going to be a identifier, a unique identifier for this specific action that the server is going to parrot back in its response so that we know which callback to invoke. Okay, so this is going to require us to implement this is going to require us to have a couple fields on this class. So let's go ahead and do that first. Let's scroll up to the top, and I'm going to initialize some stuff. I'm first going to do this action callbacks equals object, this requests equals object, and this next request ID equals 0. So action callbacks are going to be the callbacks that we're going to add to our socket, so we can keep track of what actions that we know how to respond to. Requests are going to track the individual requests that were sent to the server based off their request ID. The next request ID is going to be auto-incremented every time we send out a request. And don't worry about next request ID overflowing. In JavaScript, there is a ridiculous... The amount of numbers we can fit in a JavaScript number value are insane. You would have to send out multiple requests every second for, like, until the heat death of the universe or something. I can't remember what the analogy was, but... we're going to increment next request ID on every request so we can keep track of when the server sends us back a response, which request it's associated with. Okay, with those fields set up, let's start working on emit action. Now, emit action is going to need 2 helper methods. So let's do those. The first is register callbacks, and this will be register callbacks on action. Register callbacks is responsible for registering the success and failure callbacks on the actual socket. It's responsible for saying, okay, when the server sends me back a response, I need to do something with it. We're also going to need a pop request that's going to take in an ID. Now, pop request, his responsibility is, okay, the server just sent us back a request, and the request ID was X. I need to find and locate that request, and then return it, and then remove it from my internal representation. So what I'm going to do is first going to say, if not, this request has own property ID. This means that if the server sent us a response, but they sent us a response with a request ID that we don't actually have, so we weren't the one to actually send this request, then there was an error. So I'm going to say console log or console error event with ID was returned twice, or the server did not send back an ID. So this could also happen if the same response was sent twice, because we remove the request ID from our observable socket when it comes in for the first time. And then we'll say return. Then I'm going to say const request equals this requests at ID. Then I'm going to say delete this requests at ID. Then I'm going to say return request. So that's how we pop the request. We try to find it. If we can't find it, or if we can't find it, we error. If we can find it, we remove it and then return it. Okay, register callbacks. Basically, there are going to be 2 callbacks that we need to handle. So the first one, so these are going to be the callbacks on the socket. So we're going to say this underscore socket on action. So this isn't, we are using the same name for the response event as the request event. So let's say someone wanted to log in with a username, and then we would emit login. But then the server, once we get to the server will then emit login and then whatever data back to the client. So we're reusing the same name so that we kind of, because there's no reason not to, honestly. So we'll say Sonic on action, and it's going to take in an argument, an ID, and we're not going to deal with REST. So the server is going to be basically like client emit login args followed by request ID. So we want to capture the argument that was passed in as well as the request ID of the initial request that we sent. So then we'll say, basically we're going to say const request equals this pop request ID. If not request, then return. So the request wasn't found. Then what I'm going to say is request.nextArg, and then that's not how you spell request. And then request.complete. So this is an interesting thing. What is request? Well, request is going to be an observable subject. So if you recall from either the documentation on RxJS or the previous course I did on the subject, you'll know that request.next and request.complete, those are methods that are going to be on observable subjects. And that's basically, request is literally what's going to be returned by emit action. So when I call request.next, this method is going to be called. And then I call request.complete to finish the stream. All right, let's handle the error condition. If there's a failure when actually performing the request, I'm going to send in a different event. I'm going to say socket on action : fail. And he's going to take in an arg and an ID, just like before. In fact, he's going to have very, very similar code. We're going to say const request equals this, pop request ID. So now you might realize why I put pop request into its own method, because I didn't want to repeat this code twice on both the success and the failure. If not request, then return. Otherwise, request error arg. So if we sent, let's say, a login message to the server, but what we got back was a login : fail message, then we invoke the error on the observable. And that will signal that the stream has failed in some sort of way. The final thing I want to do is say this action callbacks action equals true. Actually, I totally forgot something. This line 67 will make a lot more sense when I add a line up here at the top. If this action callbacks has own property action, then return. Basically what I'm saying is we only need to register these once. So we keep track of which actions we've registered on the socket and which actions we haven't, so that we only do it once. Otherwise, everything will explode and the universe will end. All right, we're finally ready for emit action. First thing we need to do is build our ID. So I'm going to say const ID equals this next request ID plus plus. And then I'm going to say this register callbacks action. Then I'm going to say const subject equals this requests at ID equals new, and I need to import a subject from Reactive Extensions. And the subject I'm going to import is the replay subject. So let's scroll all the way to the top and import replay subject from RxJS. Now let's scroll back down and we'll instantiate our awesome replay subject with a replay of 1. And then the final thing we're going to do is this socket emit action arg ID, and then we're going to return subject. So the replay subject means that every time we subscribe to that subject, if it has a value, it will send it back to us. Otherwise, we'll wait. A replay subject of 1 behaves pretty much exactly like a promise. If you're familiar with the promise APIs of either jQuery or the ES 2015 overview or the QPromise library. So replay subject is basically like a promise. It'll stay not doing anything until we invoke something like next and complete or error, at which case next and complete is like doing promise.resolve, whereas error is doing promise.fail. Now remember, this request object is the same request object that we're instantiating here on this line, and the same request object that we're returning. All right, let's go ahead and test this real fast. And to test it, we know that we are emitting... Oh, callback is defined but never used. Hold on, I'm just going to delete that for a sec to make ESLint happy. But let's verify it works, and I'll scroll through the code one more time. So bundle is now valid. Let's refresh. And check that out. Username foo password bar 0, which was the request ID. So that was what was sent to the server. Of course, the client never gets resolved because we never send that data back. And that's what we're going to do in the next video. So in the next video, we're going to finish our implementation, and I'll walk through it one more time. And I'll show you guys how it works in our network tab. And we'll see you then.